Welcome IB Math SL students. Here we are working on problem number 6 from paper 2 of the May 2018 exam. And we have some trigonometry here. We have a triangle with side A is 8.1, B is 12.3, and we have an area of 15 centimeters squared, and we're asked to find the largest possible perimeter of triangle ABC. So I'm going to go ahead and sketch these two triangles first. Let's say that this is side B. You'll see why I make it side B in just a moment. And then I'll make a side A that's about 8.1. So there we go. There's side A. And let's finish this triangle off. There we go. So this is angle A, this is angle B, angle C, and side C. Again, the distances are listed. Now that's not the only possibility, and you'll notice that side C is pretty short. The other possibility is that the triangle looks more like this. So let's say that here is side B. And side A then would be, let's make it something like this. Here's side A, and here is side C. And then here's angle A, here's angle B, angle C, and side C. Now, if they both have an area of 15, and I know they're not to scale, my apologies, but obviously it's going to be this triangle that has the larger perimeter. So this is the triangle that I should be trying to solve, not this one over here on the left. Okay, so let's go ahead and set up the formula for the area. The area of any side, well, I really only have two sides. I have side area, which is not really a triangle, but here we go. The area equals 1/2 times one of the sides, which I'll label it A, times the other side, which will be side B, times the sine of the angle between them. So let's plug in some numbers. I'm going to have 15 equal 1/2 times 8.1 times 12.3 times the sine of angle C. Now if I go ahead and cross multiply by 2 and divide by 8.1 and 12.3, let's see what that does for me. I will have 30 divided by parentheses 8.1 times 12.3. I get 0.3011. So the sine of C equals 0.3011. Alright, now I need to find that angle C. Alright, so I'm going to go second sine and then go up and get my answer. And if I hit enter, I get, I'm in radian mode. I probably want to be in degree mode. This is correct, it's 0.305 radians, but I think I'd rather be in degrees. So let me go down here, change to degrees. Let's get this and hit enter, and I get 17.5 degrees. So 17.5 degrees does definitely not agree with this triangle. It does agree with this triangle. Now, just as a reminder, these two angles are going to be supplementary angles. And so the angle that I actually want is 180 minus this. So it's going to be about 162.5 is what I'm going to round it to. So I'm going to scratch the 17.5 and keep 162.5. All right, so now I have 162.5 degrees. So I have a side angle side triangle, so I'll use the law of cosines to find side C and then just add A and B. So let's go ahead and do that. I'll say that c squared equals 8.1 squared plus 12.3 squared minus 2 times 8.1 times 12.3 times the cosine of 162.5 degrees. And when I do that, I got 406.9 for c squared, which gave me c equaling about 20.2 centimeters if I round to the nearest tenth, just like we have up above. So then my perimeter is going to equal 8.1 plus 12.3 plus 20.2, and that equals 40.6 centimeters. And that's what we get for problem number 6.